Nintendo Switch. See what's going on here. I've already taken a look at the ports, so there doesn't seem to be anything going on with it that I can tell, at least not visually obvious. We can take a quick look for you so you can see. And I can take another look just to be sure that there's nothing I'm missing. I don't see any bulging or misplaced pins. It's alright to me. Now we're going to be looking at channel 1, which is on the left. And let's see what it does, if anything. Immediate 0.08 draw. And just stops there. 0.08 on both sides. Interesting. Okay. So that could be, oh, many things. Could be a 92T36, could be some corrosion somewhere. We're really not going to know what this is until we open up the switch and take a look at the board. So that's what we're going to do. We're going to open it up enough to take a look at the board, and we'll be back once we're ready to take a look. Okay, we have the switch taken apart enough to do some initial testing. Let's switch you to microscope. I just want to do some initial testing around the M92T36. Alright, and as always, we'll start with the Pi 3 USB capacitor that goes through the N92T36 to the Pi 3 USB. Okay, that side is ground. The side we're worried about is the line going to the chip, and that one seems okay. So we'll continue, and in every case we're kind of looking at the lines going to the chip. Now when you're testing capacitors, if there's two lines going to the chip, one side will be ground. But if it's just one line, that's the side you generally don't want to be shorted, and we have a very clear short on these two capacitors on the lines going to the chip. Okay. Okay. Alright, so it's just those two caps, but it's still M92T36 is the issue, it looks like. Let's check around our MOSFETs. They seem okay. We'll check our little filter. Okay, they seem alright. Let's check our test pads in the middle here. None of these should be shorted to ground. Actually, just going to go straight to ground. We can just do these connectors. Okay, and none of them are. None of these should be shorted to ground either. And none of them are. Good. Alright, let's take a look at our BQ 24193 area. And everything looks alright there. Very good. Anyway, alright, so we know we have a bad M92T36. We're going to have to disassemble the board entirely to change the chip. Well, that's not something you want to do in the housing. So we will do that and come back when we're ready to do the work. Okay, we're completely out of the housing and we're prepared to pull this M92T36. While I'm setting up my equipment, I will throw up my expected temperatures for this job. They're always subject to change if the job changes, but I'm hoping they will not. Switch you back to microscope. Alright, let's pull this chip, measure again, and put a new one on. Now we're in a little different orientation. At this point, the capacitors in question are on the right hand side, the three on the top right, and the two middle ones there. And our short has gone away. We're looking for that middle one to wet. And then we want it to grab before we take our tweezers off the chip. Okay, I feel like we're aligned. Take the heat off and then place some pressure on the chip and press down and reflow again. And we should be good. Take a look and see how we did on alignment. Real quick, I just want to check and make sure the fuse is still good. I don't know that we checked it. Yep, seems to be. And just real quick, for fun and games, let's double check our Pi 3 USB area. We didn't check it either. Might as well before we go putting power to it. Okay. Nothing appears to be shorted. Very good. Let's perform a power test, shall we? And see if we get anything resembling normal behavior. Remember when we first started, we got like a 0.08 current draw, and that was it. Just stuck. Let's see what we get now. Okay. Just hanging out at 0.15. Well, that's not really what we want to see. Okay. Alright, now go away. That's good. See if we can get that side to do it now. Okay. Now go away. Alright, good. Very good. Alright, so we will go ahead and hook up our battery squid. Our modified iPhone battery squid that we have retrofitted to Nintendo Switch batteries connectors and light. Nintendo Switch battery connectors and Nintendo Switch Lite battery connectors. Alright, and for this we will need the OEM to activate, and we will need to turn on channel 2. Channel 2 will be in the right hand side of the overlay, and what we're watching is the current. And we just want to activate it. We're plugging it in and then taking it out, and then what we want to see is current go up just steadily. And it appears to be doing that. Very good. Alright, you've seen enough. Okay. We have it together enough to check with our known good battery, or our known charged battery. Don't say known good because I've had to modify it several times because of broken cable connectors. So we just say known charged battery. Let's see what she does. We have to turn on the channel first. Watching the PSU channel 1 on the left. Okay, powering up. Okay, and it seems like everything is working alright. Let's switch it around, make sure it's fast charging on the other side. And it is. Very good. Alright, so now we will reassemble more, not entirely. I don't usually put on all the back cover stuff until I have tested dock. So we will assemble enough to just let it sit and charge its own battery for a little while, if it requires it. We don't know that it does. And then we will perform all of our tests, our Joy-Cons, our Wi-Fi, our game cartridge, and dock. Alright, we're back. Okay, we're back up and running on their battery. If you take a look at the USB meter, it is drawing 15 volts at 1 amp fast charging. It's charging the, I just hooked up the Joy-Cons, so it's charging the Joy-Cons now. as you can see. Now do you want to pull the Joy-Con and make sure it is being recognized, and it is. Excellent. Bluetooth is working. Make sure it is pulling up the networks. It is. Alright. It is recognizing the game they had in the unit. Okay, and as you can see, it is docking. So that's really it for this repair. Okay, in summary, we had a Nintendo Switch no power, port looks fine. We hooked it up to our PSU and we are drawing a steady 0.08 milliamps both ways. So we disassembled enough to do some testing. We found a short on 2 capacitors around the M92 T36. We disassembled entirely, removed the chip. The shorts were removed once we removed the chip, so we put a new one on. No shorts showed back up. Put the system back together. It powered up and tested fine, and everything seems to be working. So that's really it for this repair. I appreciate you watching. If you have any questions about the equipment I used in this video, take a look in the description below. The Amazon link down there. Everything I can Amazon link anyway. If you click on any one of those links and buy anything during that session, it will help benefit the channel. I would greatly appreciate it. If you don't want to use those, there are some other support links in the description. Please feel free to take advantage of those too. If you like the video, hit the like button, and if you want to see more videos like it, hit the subscribe button, maybe the notification bell, and you'll know when I post videos, which is usually about twice a week. That's really all I have to ask of you. Thank you for watching, and I'll see you next time.